So the focus of this lesson is going to be on angles, but it's also going to be on solving equations, okay? So the first thing we need to look at is if we have, it's a terribly drawn line, but we have two intersecting lines, okay? Every single time we have two intersecting lines, we are presented with vertical angles. Vertical angles means that the opposite angles are going to be equal to one another. So if this one is 45, this one's also 45. We are also presented with supplementary angles, also known as angles on a line, meaning that these two angles right here would form a straight line if they were connected. And we also have angles on a point where these were all connected, forming a circle which is 360 degrees. So given a line, draw a better line than that. So given a line, not much better, and given an intersecting line, I am presented with four angles. And if I know what one of them is, I can solve for one of the other ones. So we're going to say that given in this information that I know that this angle right here is 45. And I know that this angle right here is 5x. Okay? So I'm going to take the information that I know to solve this problem. So there's a lot of pieces of information here. Most important is going to be the fact that these two are equal to 180 degrees. So I'm going to do 5x plus 45 equals 180 degrees. So since I have an equation here, I think of this as two parts of my equal sign. They are both equal. My 5x plus 45 is the same thing as 180. Whatever I do to one side, I must also do to the other side. So in this case, since I'm presented with 5x plus 45, I must ask myself, what does this side have to do with this side? My ultimate goal is to get x by itself. So the first thing I'm looking at is this left side here, and I say to myself, well, I have an x here, but I also have this other number. I should get rid of it. Now I can't just decide to erase it, so I must actually subtract 45 from this side. But because these two things are equal, I must also now subtract 45 from this side. And the reason why I do that is because 45 and 45, they cancel each other out. So I'm left with 5x over here equals, and I'm going to subtract this, so that's 5 and 135. So my last step is to look at this, and I don't really care what 5x is. I really want to know what x is. So since 5x really means 5 times x, I'm going to divide by 5 and divide by 5. And that's going to give me x is equal to 135 divided by 5, which would be 27. And that is going to be my answer for x. Now, depending on what your question asks, if your question asks find x, here it is, it's 27. But if the question asks what is my angle here, I have 5x. So I must now multiply this by 5. Or as I already knew, 5x was 135. 27 times 5 is 135. And I can even put a degree sign there since I'm talking about my angles. And that is how I go from there to there. Now, of course, if I wanted to or if I needed to, I could remember that these two are the same. So this is also 5x. This is also 45 degrees. And I could have set this equal to 360. 5x plus 5x plus 45 plus 45. Let me show you that real quick. So we have 5x plus 5x plus 45 plus 45 equals 360. Now in this case, what I have here on the left side is a lot of stuff that is combinable. I can combine it. I'm always allowed to combine like terms. So I have my x's, in this case I have them next to each other. Even if they weren't next to each other, I could still combine them as long as they're on the same side. So we have 10x, and my 45 and 45 gives me 90, and it's still equal to 360. Now once again, minus 90 to get rid of that 90 there. And I get that 10x is equal to 270. Divide by 10, and I still get my same answer of x equals 27. So that's two different ways, angles on a line, using just the fact that that is a line, or angles on a point, meaning that is a complete circle. And I can solve that problem and find out what x is, or find out what 5x is.